Everybody doing well. Hopefully you got enough sleep after watching the game last night. What was your favorite commercial?
I didn't really see any like commercials that stood out, you know.
Yeah. There were a lot of feely goody commercials, that's for sure. Oh, the Eminem one, yeah. They had a bunch of them. There was one on the plane when a guy like ran into him and knocked over his drink, and yeah. I like the Sam Adams one. It was the one where they let go of the horses, and the horses ran through the town. I don't remember the Cadillac one. The 3D Dorito one was horrible. That was a horrible commercial.
Yeah, I saw that.
That was horrible. I hated that commercial. All right. All right. So again, make sure we're checking in and make sure we're all kind of paying attention here. Today we're gonna hit a relatively complicated topic, but it's not super hard or anything. And I just want to kind of make sure that we're working together on this. I'm actually probably going to go over a little bit of your homework assignment as well, or your activity for today, and then we'll kind of go from there. Okay. All right. So let's go ahead and pop up our activity for today, or our note for today. So again, when you check the notes out, it's going to have last week and this week's notes. This week's notes is down at the bottom. We're actually going to be starting on slide number 36. And so I'm going to pop that up right now. Okay. So again, plan for the week on February 7th. We're going to have to be flexible here because of the weather, but I'm hoping this is a plan that we stick to. Especially Friday with the quiz. Might have to be pushed it back to next week. We'll have to see. But I want to make sure that we're kind of close. So. All right, so today we're gonna do a few slides today, about 12 slides. And then we do have an activity B. And then Wednesday we're gonna do just a couple of slides, do a little bit more of a review, wrap up, and then do activity part E. And then Friday, plan is to have a quiz on stuff that we did last week with the star life cycle, our sun, and stuff that we're doing today and Wednesday. Okay, so 2-week quiz on that. So last week we were talking about stars, and we talked about stars in general. We talked about our sun. We talked about the life cycle of a star. And during last week, kept saying things like stars make elements, stars make this element, stars make that element. Well, today we're actually going to talk a little bit more specifically about that process of how stars make what they do, why they make what they do, and then also kind of like the formulas for how to make these elements. And so we're going to do a little presentation here. As always, if you guys have questions or comments, just put them in the comment box. I'm going to be asking you a lot of questions today too. So please pay attention and make sure that you are kind of answering those questions. So today when we talk about nucleosynthesis, that is a big word, but it's really not complicated. It pretty much sounds exactly what it sounds like. Nucleosynthesis. Synthesis means to make something. Okay, so you're making something. Then nucleo is, for nuclei, nucleus. Okay, so we're going to be making nucleus. We're going to be making element. So remember that all elements have proton, neutron, electron. Protons are positively charged, neutron neutrally charged, and electron negatively charged. So we talked about charged particles a while ago. We talked about how two positives are going to repel each other, two negatives are going to repel each other, but a positive and a negative will actually be attracted to one another. And so that's still going to be a key thing here today, is that repulsion, especially. That's going to be important. So the protons are in the nucleus. They're all bunched together in the middle of the atom. Okay. but the protons don't want to be near each other because they're all positively charged particles. They want to repel each other. So in order to put protons together, you have to have neutrons. And neutrons are holding the proton together, and they're forcing them together using a force that's called strong nuclear force. This force is very similar to gravity, where it has to do with the size of the particles and the distance from one another. And we call it strong nuclear force because it is stronger than the protons repelling each other. Okay? So the neutrons will hold the protons together. And typically, normally, you're going to have about a 1-to-1 ratio. For every proton, you kind of need a neutron to hold other protons together. So if you have 6 protons, you're going to need 6 neutrons to hold them together in the nucleus. So you end up with a nucleus with 12 particles in it. Okay? As you get more and more protons, you're going to need even more neutrons than just a 1-to-1 ratio. And we'll see that in a little bit today. Okay? The electrons are negatively charged, but they're not flying into the protons because they are moving near the speed of light. Okay, they are moving, so they don't necessarily get sucked in or attracted by the proton while they're moving. Okay, and so just like planet Earth going around the sun, it's not being sucked in by the sun because it's moving. If planet Earth were to stop moving, so sun gravity will bring it right in. We'll suck it right in. Okay, and the Earth is moving around the sun. It's actually moving around the sun quite fast. It's going through the solar system, and it's fighting the sun's gravity, and that creates an orbit. So today we're going to be talking about how we actually make those elements. So if protons don't want to be near each other, how are larger elements formed? Remember, each element has a unique number of protons. So hydrogen, which we'll look at the periodic table in a minute, hydrogen has 1 proton, it's element number 1. Helium has 2 protons, it's element number 2. Lithium has 3 protons, beryllium has 4, boron 5, carbon 6, nitrogen 7, oxygen 8, etc., etc., etc. Okay? If those protons do not want to be together, what's forcing them together? Well, how are they able to stay together? Right? And so we need the force to overcome the repulsion of protons. And the only thing in nature that is strong enough for fusion, putting protons together, are stars, or the star blowing up in a supernova. Okay? Stars have enough gravitational push that they can force the proton to be together with the neutron. And then we also talk about supernovas. Remember, supernovas are when giants, they start compressing, and then maybe they'll explode because of that compression. Well, when they're compressing, they can also make elements. Okay? So remember last week, and this is the important stuff I wanted you to know about last week. Remember that small stars, the low mass stars, they only have enough gravitational force to combine 2 protons together to make helium. So small stars make helium. Okay? Medium-sized stars only have enough gravitational force to put 8 to 6 protons together to make carbon or oxygen. Now, again, remember we also said that it's not a guarantee. Because you're a medium mass star, you're going to make this element. It has to do with the size. Okay, if you're a small, medium mass star, then you're not going to make the big atoms that we're looking at there. Okay, I guess somebody keeps trying to get in my room here. Kane, you're in the wrong room, buddy. You need to go period 4. All right, sorry. Okay, keep trying to join. Okay, anyways. So medium mass stars can make, 6 to 8 protons together. The largest stars still only have enough gravitational force to put 26 protons together. And so that's a lot of protons. That's a lot of protons to put together. Again, protons don't even want to be together at all. So to put 26 of them together is pretty impressive. And that is iron on the periodic table. Iron is also a super stable atom. Okay, so iron is very commonly the stopping point, just because it's stable. It's a super stable atom. Okay. So element 27 through 92 are formed by that supernova process, that compression before the star blows up. It can make the bigger element 27 through 92. Again, 92 protons put together. That is a lot of protons. Okay, we're going to need a lot of neutrons to hold them together. All right, so today we're actually going to practice writing out the equation on how this stuff happens. So this is called nuclear notation. So check this out with me. Pay attention because you guys are going to be doing this on paper here in a second. Kind of understanding the notation of the particles. Okay. So for example, over here, proton. The top number that you see on all of these, that's the mass of the particle that we're talking about. Proton has a mass of 1, neutron has a mass of 1. They are a thing. Okay? Carbon has a mass of 12. Carbon has 12 particles inside of its atom, inside of its nucleus. Okay? The bottom numbers are the charge or the atomic numbers. Okay? Look at proton. Proton has a charge of 1. It's positive, positive 1. But neutron does not have a charge. Neutron has a charge of 0 because it's neutral. It does not have a charge. Carbon has 6 protons in the nucleus, so it has a charge of +6. Okay. It also has neutrons in the nucleus, because that's where the 12 comes from, but the neutrons are neutral. So carbon has 6 positives and 6 neutrals, giving it a mass of 12. Okay. Now the electrons, which we're going to talk about in a second, but the electrons are particles. But we say that electrons do not have mass because they are really small, especially compared to the proton and neutrons. They're about 10,000 times smaller. Proton and neutrons are pretty small. An electron, 10,000 times smaller than that. So we say that the mass from an electron is essentially 0 because it rounds to 0 when we're talking about these numbers. Okay. All right, so we're going to practice some, and I'm actually going to draw some with you. So on a piece of paper, in your notebook, let's draw some nuclear notation of an electron, hydrogen, helium, and uranium. Let's go to a big one. You are probably going to need a periodic table. So if you click on this link for your periodic table, you will get this table here, this website. Okay, I like this website. It's modern. It's up to date. This website updates itself all the time. So as new research and new stuff comes out, these numbers can all change. But on this periodic table, you need to know the atomic number or the number of protons in the nucleus. Hydrogen had 1, helium had 2, lithium had 3, beryllium 4, boron 5, 6, 7, 8, 9, 10. They go in order left to right, top to bottom. Okay? The mass numbers are these guys down here below those numbers. And note that they are decimal, they are averages. Okay? So the number you might get on a worksheet might not match the periodic table, but it should be close to that number. Okay? And that's because it could be an average. So carbon, for example, is at 12.01. Carbon sometimes is 12, sometimes it's 13, sometimes it's 14, sometimes it's 11. Okay, it could be different things, but the average amount, the average weight of carbon is going to be 12.01. Okay. All right, so I'm going to go to a drawing tool, and I'd like for you guys to draw this with me. What is the mass, or what does an electron look like? So let's do this here. Okay. So we are going to draw an electron, or we're actually going to do the notation. So take a wild guess. What's the symbol for an electron? So in the chat box, we're all going to need to start talking here. So wild guess, what's the notation for an electron? What's the symbol? If proton is P, and neutron is N, and carbon is C. Yeah, so an electron is just simply E. Yeah, we do add a little negative on there just to let people know that is a negative electron on there. Okay. So the bottom number is going to be the charge, and the top number is going to be the mass. And we do a superscript and a subscript. So what's the charge of an electron? Of one electron. Charge of one electron. It is -1. Very good. Okay. Now the mass we say is 0. So if proton has a mass of 1, an electron would be 10,000 times smaller. So we just say that it does have mass, okay? I do want to be very clear about that. An electron is a particle, it does have mass, but it rounds to 0. It's really, really small, okay? So we just say that the electron mass is 0. All the notation that we're going to do are rounded to the nearest whole number, okay? All right, so let's try hydrogen. Hydrogen's symbol is H. What's the charge, the atomic number? How many protons does hydrogen have? Again, you might want to look at the periodic table. You're going to have to bounce back and forth between periodic table. What's the atomic number of protons for hydrogen? Hydrogen is 1. What's the mass of hydrogen? Round it to the nearest whole number. 1. That's right. Hydrogen has mass of 1. Did that look familiar? Look on the last slide we did. That's the same as a proton, right? Hydrogen and protons are the same thing. It's just one proton. So that's the same. Okay. All right, now let's do helium. What's the atomic number of helium, the charge, number of protons for helium? We got a couple different numbers there. So the atomic number of protons or the charge for helium is 2. Cameron, what's the weight? What's the mass of helium? Yeah, so the mass of helium is going to be 4. Okay, so the mass is 4, and then the number of protons is 2. So helium is the second number on it. All right, uranium. So you have to look at the periodic table down to the very bottom. What is the atomic number or the number of protons or the charge of a uranium nuclide? All right, at 92. What is the mass of uranium? $238. So if you notice, the top number is always going to be the same or bigger than the bottom number there. Okay, now, so that means that uranium had 92 protons. Okay. Neutrons are going to equal the mass minus the number, the atomic number. 238 minus 92 for neutrons. How many neutrons does uranium have? Uranium is going to have 146 neutrons to hold 92 protons together. And again, this is where that 1-to-1 ratio doesn't exist anymore. You need a lot of extra neutrons to hold uranium together. Okay. Now, uranium-238 naturally producing, it literally can dig it up in the ground. just like you would a lot of minerals. If we were to take 3 of those neutrons away, and we were to make uranium-235, that's you taking away the glue. That's you taking away the neutron to hold it together. That uranium is going to freak out, and that uranium is radioactive. That uranium is not happy, it is not stable, and we can use that as energy. We can use that energy in the form of nuclear energy. We could also use that in the form of nuclear bombs, okay, like that. Okay. So the unnatural elements, that's a good question, Anna. So the unnatural elements are man-made in a laboratory. And what they do is they have machines that will basically pressurize and slam atoms into each other, and they make bigger atoms when they slam into each other. This requires a lot of energy. So if you think about the energy of a star, to slam these atoms into each other to make bigger atoms. You can make any element you wanted on the periodic table. The problem is that it costs a lot of money to do that. So for example, I can make gold in a laboratory all day long, but I'm going to lose money making the gold when I can just go to the store and buy gold, right? So making these elements man-made requires a lot of energy, okay? And to where it's not worth it. It's not worth making those elements, okay? But humans, we do have the ability to manipulate and apply energy to these guys. Okay. All right. So it's called nuclear energy, but that's how. So right now we have 118 elements on a periodic table. 92 of them, or 90 are natural. So that leaves you with 28 that are man-made. And there are companies that will make elements for you depending on what you're looking for, and that's how I get my stuff for your chemistry labs and things like that. There are companies that will make you elements. Most of them are chemical reaction, not nuclear, but you can actually fuse and split atoms on purpose and to make new atoms. However, they require a lot of energy, and it's really expensive, and it's not really worth doing. Uranium is worth doing, especially in like weapons world, because it releases a ton of energy compared to other traditional explosives. In the nuclear world, just like a little pill of uranium, that is equal to like truckloads of coal and oil and things like that. So making uranium for nuclear power is worth it. You're going to pay for it as a customer, but you're paying for oil and coal too, so it doesn't really matter. But yeah, we can do. It's called nuclear fusion, nuclear fission. We can control it to a point. Now you guys need to invent a way to make nuclear fission and fusion, make both of those feasible and cheaper, and then essentially we'll end up having not free energy, but really inexpensive energy if we can do that really cheaper. If we can figure out a way to do nuclear fusion and fission, controllable and cheap and fast, you solve a lot of the world's problems just by doing that. All right, anyways, let's go back to the notes real quick. Okay, so what's happening in the actual stars? So in the actual stars are hydrogen. They only have one proton. That's hydrogen. That's what stars do. So step number 1 is, in order to make bigger elements, stars try to put 2 protons together. Because that's all they are. That's all they have. They have protons. They have hydrogen. Can they do that? Can they put 2 protons together? In your chat box. Can you put 2 protons together? Do 2 protons want to be bonded together? No, they don't, Caleb. No, because they're going to repel each other, right? They're going to repel each other. So, as Anna just said, we need to get ourselves some neutrons first. And so what will happen is that one of those protons will change into a neutron. And so how does that work? Well, they can, because proton and neutrons are things, they're made up of smaller things that are different. If the proton loses its positiveness, it can become neutral and turn into a neutron. And so that's what happens. In stars, in this process of nuclear fusion, the proton, one of them, will lose its positiveness. And that is called a positron. Okay? Called a positron. It will lose its positiveness, and then that proton will turn into a neutron. Okay? But even then, though, we haven't really changed a whole lot there. Okay? It's still hydrogen itself. So real quick, I want to write that down. I want to show you what that looks like in an equation form. Okay? So we can do this on a piece of paper in your notebook. You might see it again, hint, hint, wink, wink, on your homework. So step number one, we're going to put a proton together, or again, that's the same as hydrogen, remember? Proton with a proton, but that's not going to work. Okay, that's not going to work because helium can't stay together without a neutron. So the proton is going to lose its positiveness, and we're going to call that a positron. That has no mass, but it does have a positive charge. Proton is going to lose that. And so what's going to happen here, 1 plus 1 equals what plus 1? 1 plus 1 equals what plus 1? Equals 1, right? 1 plus 1 equals 1 plus 1. 1 plus 1 equals what plus 0? Yeah, this happens slow. Yeah, so it'll be 2 plus 0, right? And then again, that is still hydrogen. It's still element number 1, okay? But hydrogen with a neutron, okay? That's still hydrogen, but hydrogen with a neutron now. Okay? So we try to put 2 protons together, not going to work. I have to add a neutron first, and then I'm going to lose some of the positivity. And the positivity is called a positron. And that, again, that is weird, but that's essentially what happens. Is you take the positiveness out of a proton, and it becomes neutral. It becomes a neutron. All right, so step number 2. Let's go back to this slide real quick. Step number 2 is now we're going to take what we made before. Now we're going to take the hydrogen with the neutron, and we're going to add a proton. And that does work. We can now add 2 protons together, okay, because we have the glue holding them together. Okay? So the previous nuclei, which is hydrogen 2, has got 2 particles, 2 is the new mass, can fuse together with another proton. This creates helium with 2 protons and 1 neutron. That is helium-3. You guys see the 3 particles? It's helium because it's got 2 protons, but it's got 3 particles called helium-3. Now, that is not super stable, though. That's not very happy. Because, again, these protons are still going to repel each other. It would like to have another neutron. It would like to have another neutron in order to stay together. All right? So, again, let's write that out. Let's show you what that looks like. Maybe. Hold on here. Come on now. My whiteboard is acting all slow. Alright, so let's erase all this. Alright, so let's now, so step 2. So we take what we made before, which is a hydrogen, and we try to add it to another proton. Well, that's easy. 2 plus 1 equals 3. 1 plus 1 equals 2. That is a new atom. That is atom number 2, which is helium. Okay? That's it. Done. Simple. Easy. So again, if we go back to the drawing, we have 2 protons and 1 neutron. Again, these protons are positively charged. They're going to kind of repel each other, right? But they're able to stay together because of that neutron. That's not super stable. We would like to get another neutron in there. Well, easy enough. We can take another one of those guys right here. Then that neutron can leave and go here. Right? And that would make helium 4. And then what will happen to these guys down here? They're going to repel, right? They're going to repel and go away. So if I take 2 of these guys here and I add them here, okay, that's going to, yeah, they're going to repel and they're going to make 2 hydrogen. Yeah, they're going to repel and break and go away from each other, okay? And so this is very stable, okay? That, you know, again, the three particles is not super stable. It does work, but it would rather be a little bit more stable. So last step, this is step number 3. You put 2 of those guys together. The neutron can join up with one of them, and then the other 2 protons just break apart and they say, see you later, bye-bye. Note that it's still balanced. I have 4 red circles, 4 red circles. 2 blue circles, 2 blue circles. Everything is still balanced there, okay? We're not creating matter. We're not destroying matter. It's still there, still balanced. We're just moving around. And again, this hydrogen over here is much more calm and stable than this helium. This helium over here is much more stronger than this helium right there. So that's the last step. That is the calm, stable helium. And then we still have 2 protons there, 2 hydrogens that can go off and do the same cycle again and again and again and again. Okay. All right, so other nuclear reaction. Again, this is fusion. You put 2 little atoms together to make a bigger atom. It's just a simple math problem, okay? Let's say we'll put helium and lithium together. 4 plus 7 equals 11. 2 plus 3 equals 5. Look on a periodic table. Number 5 is boron, right? Letter B. All right, first person to chat. First person to put it in the chat box. Name an element. We'll make it. Okay, what element do you want us to make? So first person in the chat box, what element do you want us to make? All right, gold. I think gold was the first. Nope, and one was silver. All right. So let's do silver. All right, so we're gonna need a periodic table. So pull up periodic table, find silver. Silver is kind of hard because silver is not the letter S. Silver is the letter AG. So we're going to make silver, so we're going to put AG over here, and we're going to make it. So look on the periodic table toward the middle there. It has a mass of 108. Again, looking on the periodic table. And it has the atomic number 47. So what plus what will give me 47? Let's try to do 2 different numbers. Which we'll have to anyways, because it's an odd number. So what plus what will give me 47? All right, yeah, that's easy enough. So 23 and 24. All right, so element number 23, look on the periodic table, is vanadium. Element number 24 on the periodic table is chromium. Okay. So we can look on the periodic table, vanadium has 51 on there. So what plus 51 would give me 108? $57, right? Now, note that that number does not match the periodic table. That's okay, because periodic table is an average. All right, periodic table is an average. And there you go, there's a nuclear fusion reaction for silver. Does not mean that it's guaranteed at all, okay? But that is a possible reaction if we wanted to make silver. So again, you're balancing the bottoms, you're balancing the tops, and you go. Okay, now let's take a look at your homework assignment for today. And I'll be honest with you, it is kind of homework assignment. Probably not going to be able to finish it all today. So if you go to your activity on weekly schedule, said we're going to do activity D than dog today. Again, this is due on Friday, but I will do it tonight. I'll do it right now. Okay. Make your own copy. And then let's take a look at this. So you're going to fill in the highlighted boxes and, balance the equation. So I'll do some with you right now. That's right. We'll do some homework together right now. Okay. So let's pop it up. It looked like this. Okay. So you're going to have 9 practice problems, and then you're going to do the one that we did just a couple seconds ago in the stars. So number 1, super easy. What plus 4 will give me 226? What plus 4 will give me 226? Yeah, so 222 goes there. What plus 2 give me 88? E6, right? What is element number 86 on the periodic table? Because again, that's 86 protons. Down to the bottom right. And that is wait on. All right, so number 2, what plus 0 give me 14? Whoa, that's pretty tough, right? 14, I'm not even gonna wait on you guys. What plus -1 give me 6? Yeah, you gotta be careful, okay? An electron is negative. So it's a -1 plus 7 would give me 6. So if I look on the periodic table, number 7 is nitrogen. I'll go down here. This one's got more boxes we need to fill in. What is element number 1?
Hydrogen.
Yeah, hydrogen. All right, so carbon, what's this number? And again, that number is never going to change for carbon. It would always be that number.
8.
Not for carbon.
Oh, wait.
Well, we got this box. We'll fill out first.
Oh, okay, I see.
So what number is carbon on the periodic table?
It's 6.
This will be 6. So now 7 plus 1 equals 6 plus what? 6 plus 2, right? Because in order equal 8. So 14 plus 1 will equal 11 plus what? We're getting a little slow on this. Yeah, so it'll be 4 on that. Yep. And what is element number 2? Helium again. All right. We have a couple minutes left in class, but again, you guys are still with me for 30 minutes if you guys want to finish this up today. I want to look at what stars do to make helium from hydrogen. This is what we just did a couple minutes ago. The step 1, step 2, step 3. Now, the stuff in the blue box from step 1 that you make will go into step 2. The stuff you make in step 2 will go into step 3. Okay, so the blue goes into blue, green goes into green. You're also going to need your notes on the missing stuff. So if you look at your notes, the very first thing we try to do is try to put 2 protons together, which are hydrogen. We try to put two hydrogen together. That's not going to work, right? So we got to get rid of a positron. Okay, we got to get rid of the positiveness in order to make that work. So 1 plus 1 makes what plus 0? And then 1 plus 1 make what plus 1? Okay, 1, okay. And that is still element hydrogen, okay, because it's still number 1 for hydrogen. It's heavier now, it's got the neutron. So we're going to put that down here in the blue box. And then step 2, we try to add it to another proton again, right? Then we go from there. All right, so check out your note. Check out all the stuff that we've done. Okay, this is your homework assignment. You have 9 problems, and then this one for how to start. And then activity on Wednesday, the video, okay? And then if you guys want, you guys can finish that entire week of science stuff if you wanted to. Again, we want to be a little bit flexible this week about the schedule, just because of all the craziness for weather that might happen. Right? As always, if you guys have questions, please be sure to ask. Okay, and then we'll talk a little bit about this also tomorrow. With that. All right, that's technically the end of our class time. So it is considered homework. It is stuff that this is due on Friday. So you have between now and Friday to do it. But again, I would work on getting it done right now. Okay, that's what I would do. All right, I do have some mentoring I want to do today. So Anna, Braden, Gavin, I'm gonna call you guys in a little bit. I'm gonna go in that order. I'm gonna start off with Elizabeth first, then Braden, and then Gavin. Do a little bit of mentoring with you guys, then we'll check back from there. Okay. All right, you guys are here for another 30 minutes before we go off to lunch. And so I'm gonna go ahead and stop the video. I'm gonna go ahead and stop my stuff here.